2, 3, 0, start. They're beginning the live streaming.
A very good afternoon, Principal Ma'am, Vice Principal Ma'am, Vice Principal Sir, teachers, dignitaries, viewers, and participants. I, Shreya De, on behalf of the Physics Quiz Committee, welcome all of you to PHOTOPHYSICS 20, the Inter-House Physics Quiz of DPS Ruby Park. Physics, hands down, is the most fascinating subject I have ever come across. Why is physics so important? It is fundamental. Its principles are used in the foundation of many other sciences. It helps us investigate. It inculcates intuitive thinking, helps us appreciate our universe, and it is the basis of much of technology. It teaches people to accept reality with awe and admiration, not to mention the joy and amazement that comes with it. We would like to express our gratitude to the Physics Department and HOD, Suprabhat Sir, without whose guidance and support, we would be like the solar system without its sun. We know that 2020 has been exceptionally distressing for everyone, so we hope that PHOTOPHYSICS 20 reinvigorates your love for physics. With that being said, here is a fun little physics meme about 2020. Here are the participants of PHOTOPHYSICS 2020. From Chenab House, Class 11, we have Mrinmoy De and Class 12, Ayuntik Burman. From Ganga House, Class 11, we have Jyotirmoy De and Class 12, Pragyayan Guha Roy. From Jhelum House, we have Srijan Bose from Class 11 and Class 12, Momita Paul. Kaveri House, Class 11, Medhir Aryan and Class 12, Shayantika Shaha. Narmada House, from Class 11, we have Shayok Das. Class 12, we have Shiporno Banerjee. From Teesta House, Class 11, we have Olivia Das. And Class 12, we have Sarthak Anand. With that being said, without further ado, let us begin with the fascinating journey of PHOTOPHYSICS 20 as we unravel the mysteries of the universe. I now hand over the proceedings to Abhranil Mitra.
The quiz consists of 4 rounds, namely ERGOSPHERE, Photon sphere, Event Horizon, Singularity. Now I would like to request all the participants to note that in the final round Singularity, they shall be having common questions, connected questions from first 3 rounds. You are supposed to note the connected questions properly. Beginning with the first round, that is ERGOSPHERE. The ERGOSPHERE is a region located outside a rotating black hole's outer event horizon. The first round will be conducted as follows. Participants are to keep their videos on at all times. Each correct answer fetches your team 10 points. For an incorrect answer, your team will be given -5 points. All questions have to be answered. During the 1.5 minutes of discussion time given, only the members of that team can unmute and discuss in between themselves. Lastly, the decision of the quizmaster is final and binding. With this, I pass it on to Avi to conduct the first round. Thank you.
Thank you so much, Abhranil. So, ladies and gentlemen, boys and girls, we are about to begin with PHOTOPHYSICS 2020. So, tighten your seatbelts wherever you are sitting, as we are about to enter ERGOSPHERE. It is likely that you will face a lot of turbulence in this region. So, sit back and enjoy. We begin with the first question for Chenab House. Are you ready, Chenab House? I extend up to millions of kilometers, but your eyes can see me only when it is totally dark. My temperature is greater than 1 million Kelvin. Quantilionic, Fraunhofer, and emission are my types. Who am I? Chenab House, your time has started. You can unmute yourselves and discuss.
Antik, do you know the answer? Are you sure about it?
Do you know?
Please be quick. Ayuntik and Mrinmoy. Remember that you have to answer the questions. Answering the questions is compulsory. Otherwise, you will be awarded -5 points.
Is the answer sun?
So you want to go with sun. Do I take that as your final answer? Chenab
30
House,
seconds left.
do I take that answer as the final answer? Please look at the question very carefully.
I think.
Seconds
Do you
left.
want to answer? We want to go with sun.
All right, so Chenab House wants to go with sun. The answer to this question is it shares its name with a virus, and the answer will be it is stellar corona, and it shares its name with coronavirus. And we start our quiz with a good note. Never mind Chenab House. We unfortunately we have to award you -5 points, but don't worry. The quiz is designed in such a way that we offer you a lot of opportunities to increase your score further. With that, we move on to the second question for Ganga House. Om, please move to the second question. All right. The triboelectric effect is the principle behind charging of a Van de Graaff generator. You need to name another very common application of this principle. For those of you who don't know what is a Van de Graaff generator, I have provided a schematic diagram of this generator in this slide. Ganga House.
Hello, Jyotirmoy.
Yeah.
Hello.
Hello.
Do you have any idea?
Not in such terms.
You have been doing it since childhood, remember that.
Yes. Well,
And I would request all other participants to please mute themselves.
please wait a minute.
Carefully see this picture. This is demonstrating something.
Yes. Do you have any idea, Jyotirmoy? Yes, I'm not getting any idea.
Is it? I'm also not quite sure of.
I'm also not quite sure of. Wait. Let me think.
10 seconds left.
Wait.
Please be quick.
Okay. To reduction of static charge on aircrafts due to air friction.
No, Ganga House, that is not the correct answer. The correct answer is any kind of charging based on friction or rubbing will come under triboelectric effect. That is charging a comb by rubbing, or charging of a glass rod by fur, or any other answer. So unfortunately,
I told to
no,
reduction
Ganga
of
House,
static
we
charge.
can't accept your answer. I'm
Okay.
extremely sorry. Okay, never mind. We award you -5 points, but never mind. All right, so we move on to the third question. Third question is for you, Jhelum House. Be ready. See this picture. What is the name of the empirical result mentioned below? Lambda equals b times n square by n square minus m square, where the value of m given is 2 and lambda is the wavelength. Jhelum House, take your pick. You can unmute yourselves and discuss. Any idea, Jhelum House? You have done this in your curriculum. Srijan Bose and Momita Paul.
This is Rydberg's number. Like the
So you are saying Rydberg's number.
Like atomic emission.
Be a little more specific.
10 seconds left.
Be quick.
Time up.
All
The
right.
atomic spectrum.
You were close to the answer, but it was not the exact answer. The answer would be, this is the Balmer's formula, because the value of m given is 2. I have specifically mentioned that. So this corresponds to the Balmer's formula given by Balmer himself. And this formula was later on generalized by Rydberg to get the wavelength of spectral lines. All right. So unfortunately, we have to award you also -5 points. The next house, which is the Kaveri house, for question number 4. And all houses are requested to note this question carefully, because this will be used later for a connect question. See this picture very carefully. I hope you have seen this earlier. The person I'm talking about had offered an explanation of the infamous Michelson-Morley experiment. Einstein had once said, "For me personally, he meant more than all the others I have met on my life's journey." Who am I talking about? And what was this Michelson-Morley experiment? Kaveri House, go ahead.
Do you have any idea?
interferometer or
Hmm.
Michelson-Morley.
He once
Do you know
complimented Nikola Tesla. So can it be? I don't know this Michael Morley experiment. So can it be Nikola
Interferometer?
Tesla?
One hint I can give you is that this person was very close to Einstein.
This is Bose. Bose-Einstein
Nikola
condenser, remember?
Tesla
Mm,
can be.
I think it can be Nikola Tesla. But do you know this experiment, Michelson-Morley
No, I don't know
experiment?
this experiment.
Mm.
The Michelson-Morley experiment was basically an experiment conducted by Michelson and Morley to measure the velocity of the fictitious luminiferous ether. It was a experiment that was later proved to be incorrect, but it established the non-existence of luminiferous ether.
I think it can be Nikola Tesla. I'm not sure.
Nikola Tesla.
10 seconds left.
Okay,
Okay,
so Kaveri
Nikola
House
Tesla.
wants to go with Nikola Tesla. Okay, let's see what is the correct answer. I am talking about Henry Lorentz and Michelson-Morley experiment, as stated by Suoji, was an attempt to detect the fictitious luminiferous ether. Lorentz was the person who proved that there is nothing in the world called luminiferous ether, which earlier physicists believed that light travels through this medium. All right, so we'll have to award you -5 points, Kaveri House. Moving on to the next question, I would request all other participants to please mute themselves to avoid any background noises. Narmada House, this question is for you. Look at this diagram. This diagram represents the relation between different points in space-time. This is also used to illustrate the structure of space-time regions containing black holes. What is this diagram called?
All participants, please take note that this is a connected question to the last round, Singularity. Please note all the details of this question. Thank you.
Do you know anything about it?
I'm sorry?
I'm not sure exactly.
Narmada House, can you relate it with current affairs? Suparno and Sayok, your time is ticking.
What do you think, Shaparno? Not exactly sure.
Please think.
Is this the space-time diagram? Not.
Yes, this is a space-time diagram, as you can see. But this diagram has a specific name. It was given by a scientist.
Ten seconds left.
Any clue?
Something called the Hawking curve or anything like that. Hawking diagram.
So you think it's
Time up.
something related to Hawking? All right, let's see. The correct answer will be, this is a Penrose diagram given by Roger Penrose, who was the Nobel Prize winner of 2020 in physics. We'll have to award you -5 points, Narmada House. Moving on to the next question. For Teesta House, question number 6 on your screens. Look at these two pictures carefully. How do you relate these two pictures? There is something which connects these two pictures. You need to tell me a connecting link. Teesta House. If you are facing any difficulties, let me tell you that the man on the left is Fermi, who was a popular scientist. And as you can see on the right, we have a poster of KGF movie. I can see smiles all around. Any clue, Teesta House?
Do you know the answer?
Idea means a connection like means I don't know. KGF movie and for me.
We have to tell what is the connection between these two pictures.
Yes.
For me and
the full form of KGF is Kolar Gold Fields. It is a gold mine, let me tell you.
okay, good. First picture was off. Means can you repeat the name of the scientist?
Yes, he was Fermi.
For me.
10 seconds left.
Please be fast, Teesta House.
Okay, is it means related to the golden record which they sent in the Voyager?
No, Teesta House. No. The answer would be, the connecting link between these two pictures is neutrino, because neutrino was discovered, atmospheric neutrinos rather, were discovered in this Kolar gold fields inside an iron calorimeter, and neutrino, as you know, is a type of fermion. So neutrino is something which connects Fermi and Kolar gold fields. So this is your answer in front of you. Never mind, we'll have to award you -5 points, but I would request all the participants, do not worry, because the quiz is designed in such a way that even the house which is trailing, we can give you an opportunity to come to the top. So do not worry. From here, I pass on to my friend Obronil to take the proceedings of the quiz further. Obronil, over to you.
Thank you so much. With this, we come to the end of the first half of the first round. Now I shall be conducting the second half of the first round. However, we will be going in an anti-clockwise manner, starting with Teesta and ending with Chenab. So are we all ready? Let's go. Teesta House, question for you. Home, please. Teesta House. In 1903, Max Planck gave this infamous Planck's radiation law, which was the foundational aspect of quantum mechanics, to resolve an ultraviolet catastrophe. So what was this ultraviolet catastrophe?
Okay, So means can I answer now? Olivia,
Yes, please.
do you want to discuss first or?
If you know, you can answer.
No, I think it's about the black body radiations. Means the curve that was shown by initially it was a means hyperbolic curve, which was later had to be corrected as it had a peak value in the mid range and then means low value in the starting. Then it raises to a maximum and then it again decreases.
Mr. House, can you please give me the name of the law? I just want the name of the law. Can you please give me the name of the law,
Name of
please?
the law. Okay. Ultraviolet catastrophe.
Teesta House, you are very close. You
We are
just
very,
have to
very
name
close.
the.
Is it
No
something
idea.
to do with the black body radiation?
Yeah, means the graph was first incorrectly described and then it had to be corrected. That was the ultraviolet catastrophe. But there is a name of the law which they want to
You
know.
are just one step behind the answer.
Means it's in my head. I can't get it out. No idea.
10
Olivia,
seconds
do you want
left.
to take a guess?
Mr. House. Okay, never mind, Mr. House. You are very close to the answer, and the answer is Rayleigh-Jean's law. Since you are so close to the answer, we are bound to give you partial marks, plus 5 points for Teesta House. Better luck next time, Teesta House. Moving on next, we have Narmada House. Let's see. Narmada House. Discovered in 1783, this elliptical galaxy is the home to several trillion stars, a supermassive black hole, and a family of about 15,000 globular star clusters. In comparison, our Milky Way contains only about 150 globular clusters. Name this galaxy. As you can see, there is a picture of this galaxy out here.
I don't know.
Sorry?
Does this look like Andromeda?
Narmada
I'm not
House, are you
exactly
sure?
sure. No, not now. Just so.
Not now.
Come on, Narmada House. Feel free to discuss amongst yourselves, your house partner.
I'm not sure if this looks like Andromeda.
I need an answer. Give me an answer first. Let's see.
Does this look like nebula stars planet galaxy anyhow?
Do I take that as your final answer?
Shayok?
Thinking, I'm not sure.
I think we should go with Andromeda. It won't be Andromeda. I think about it.
I'm taking Andromeda as a final answer. Andromeda.
No, you go with nebula stars galaxy.
I'm up. Nebula stars. I'm sorry, Narmada House. That is not the correct answer. The correct answer is Messier 87 galaxy, M87. -5 for Narmada House. Moving on next, we have Kaveri House. Kaveri House, question for you. Unlike Cherenkov radiation, this is a form of electromagnetic radiation emitted when a charged particle passes through a boundary between two different media. Name the radiation.
Have any idea?
See, Kaveri
Wait.
House.
I know it, I think.
Wait.
Electromagnetic radiation, charged particle. X-ray or something. X-ray.
I think it can be X-ray because look, X-ray can pass through different medias.
I was also thinking that only.
Do I take
X-rays.
that as your answer? Final answer?
No.
Wait.
Come on. Give me an answer. Come on.
Charged particles.
This is a trap. Don't fall into the trap.
X-ray can be.
I somehow
But
think it can be X-ray.
so in X-ray we have charged particles. We have charged particles. UV rays. Microwaves.
I was thinking about micro, but I'm not sure about
your
microwave.
final answer?
Microwave.
10 seconds
Microwaves.
left.
Microwaves.
give
You
that?
take microwaves. I'm
Are
sorry,
you
Kaveri.
sure?
I'm sorry, Kaveri.
Time up.
Microwave is not the correct answer. It is not the correct answer. The correct answer is transition radiation. I said in the interface between two different media. -5 for Kaveri house. Moving on to Jhelum house. Next question for Jhelum house. Are you ready, Jhelum house? Okay. Next question, please, Om. Associated with the invention of the crescograph, he also made numerous contributions to the wireless transmission of information using microwaves. Who is this famous Indian personality?
Jagadish Chandra Bose, final.
Are you sure? Jhelum house?
Sure.
I think it's Marconi.
No, it is.
What do I take as a final answer,
It's
Jhelum
Bose.
house?
Marconi who didn't have any contribution to the crescograph.
Okay, fine. Go with his answer only.
What is your
We'll go with
final answer, Jhelum house?
Jagadish Chandra Bose.
Yes.
Absolutely correct. It is Jagadish Chandra Bose. Plus 10 points. The first time we are awarding a full point to a house, Jhelum house. Congratulations. Plus 10 for you. Moving on to Ganga house. Let's see. Next question, please. Yes. A very famous English scientist who holds several accolades to his name, along with a dedicated laboratory also in his name, in the University of Cambridge. He was the first to yield the accurate values of the gravitational constant via laboratory experiments. Who is he? And by the way, all participants, please take note of all the facts in this question, because this too is a connected question which would be helpful in the last round.
Hello.
Ganga house,
Hello.
name the personality. Who is he?
This is the gold wall setup that was formed to. I can't remember the name of the site.
Is he Henry Cavendish?
Yeah, Henry Cavendish.
Answer?
Henry Cavendish is
Henry
the
Cavendish.
final answer. Yeah.
Final answer. Pakka?
Yes.
Okay.
Yes.
Plus 10 points, Ganga house. No stopping you. That is the correct answer. Henry Cavendish is the actually correct answer. Plus 10 for Ganga house. Bravo. Moving on to the last house of this round, Chenab house. Ready, Chenab? This lens uses metamaterials to go beyond the diffraction limit. The latter is a limitation to the fineness of resolution in a conventional lens. A slab of silver was proposed as the metamaterial. Name this lens. And here you can see an image of a pollen particle which is formed by this lens. What is the name of this lens, Chenab house?
Rinman, do you have any idea?
Do you want to go with any answers?
Feel free to discuss, Chenab house.
We have to name the type, means the name of the material, right?
Name the lens. You just need to name the lens.
Okay.
Come on, Chenab house. Give me an answer, Chenab house. Come on.
Even the nickname of the lens will do.
Antik, you can go with your.
10 seconds left.
I have no idea.
Time up.
Any answer, Chenab house? Okay, the answer is super lens, which is also nicknamed the perfect lens. Sorry, Chenab House, -5 for you. With this, we come to the end of the first round, and I hand over to Shreya to announce the standings so far in the first round. Thank you.
Thank you, O'Brien. That was indeed a very intense round, which has set the mood for the entire quiz. Now, the ranks stand as follows. In the third position, with a score of -10, we have Kaveri tied with Narmada and Chenab. In the second position, we have Teesta House with a score of 0 points. And leading the scoreboard, we have Jhelum and Ganga House with a score of 5 points. Thank you. I now hand over the proceedings to Shruti.
Thank you, Sneha. If the first round is so thrilling, one can imagine how exciting the entire quiz will be. So, we take our quiz towards the inside of a black hole. We have finally reached the photon sphere. Although the black hole itself is dark, photons are ejected from this region in the form of jets. However, the gravity here gets so strong that the photons bend themselves, forming bright circular rings. The second round, the photon sphere, will be conducted as per the following details. Participants of all the houses are requested to keep their videos on at all times. Each question of this round consists of 20 points, 10 for naming the phenomena and 10 points for explaining the phenomena. For an incorrect answer, 5 points will be deducted from the house score. All questions have to be answered. During the 1 minute and 30 seconds of discussion time given to you, only the members of that team can unmute and discuss between themselves. And the first answer given by them will be considered only. Now, in the first round, I have noticed that there was some hesitation in the discussion. Please be free to discuss among your teammates. And lastly, the decision of the quiz master is final and binding. So we move on to the second round. Om, may I request you to move on to the first question? It is for Chenab House. Mrinmoy and Ayantik, please have a careful look. It's an animation.
Recently, some friends of mine went to the Gordon Dam in Tasmania, which is 126.5 meters or 415 feet high. Then they dropped a basketball over the edge. You can see that the basketball gets pushed around a bit by the breeze, but it lands basically right below where it was dropped. Now watch what happens when they drop another basketball, but this time with a bit of backspin.
Whoa, look at that go! That's incredible.
So, Chenab House, as we could see in the animation, a group of friends visited a dam to conduct an experiment. They dropped a basketball from a great height, and we observed that if it is not given any spin, it fell straight down. While if it is given a little of backspin, it has traveled a few meters ahead following a curved path. My question to you, Chenab House, is to name this phenomena and explain it very briefly. Your time starts now.
The name of the phenomena is rotational motion, as if we give a spinning omega to a velocity or an alpha acceleration, it will move a certain distance because of because of their one because of translational velocity and rotational velocity both.
I recommend you discuss the answer with Ayantik.
Mrinmoy.
Yeah.
Don't you think it is due to Bernoulli's theorem?
Ayantik, please go ahead.
You can go with it.
Or rather, viscous drag?
You go ahead with Bernoulli.
Please name the phenomena and explain the principle. You have to name this phenomena in which the ball follows a curved path.
10 seconds left.
I think you go.
Please
But
be quick.
It is due to the turbulent flow, where the forces of air on all the sides of the ball are unequal due to the
Time up.
spinning twist during
Time
the
up.
ball.
Time up.
Okay, so as I could make out from your answers, you have given the explanation correctly. It is indeed the Bernoulli theorem. But however, the phenomena depicted in the animation is the Magnus effect. I would request Om to give Chenab House a partial marking of 10 points. Well done. Well done, Chenab House. Now let's move on to Ganga House. This is the question for Ganga House. It's for Pragyan and Jyotirmoy. Om, please start the animation. This footage is silent, so do not expect any audio. As we can see, the professor is trying to explain something. We have seen that this system's size can be controlled using a rope. As we can see, this system, when it is in the fully expanded state, it is given a bit of spin. As it is contracted, rotates extremely fast. Please watch the complete animation. We observe that on contracting the system, it moves extremely fast. It spins rather extremely fast. My question to you, Ganga House, is to name the system depicted in the animation and explain the principle behind it. Your time starts now. You may discuss.
Jyotirmoy, I think it is the conservation of angular
The
momentum.
conservation of angular momentum.
Yes.
Should we go
Okay,
with that?
No, wait. Let me think once.
The angular momentum has to remain constant. Therefore, if you contract the radius,
Yes,
obviously
in
it will.
contract the radius, it will.
Okay, concentrate
Wait,
on the name of the system. This system has a specific name. You may discuss.
Do you know what is the experiment?
No, but obviously it is shrinking and the thing is rotating fast. So conservation of angular momentum is quite.
Ganga
It
House, are you
can.
full and final?
No, wait. How much time we have more? Wait, let me think.
Pragyan, please concentrate.
Let me think.
10 seconds left.
Angular momentum এর কি হতে পারে?
The structure has a specific name. What is that? I mean,
Time up. Time up.
That structure is
Okay. So as I could make out from Ganga's answer, they have correctly named the principle behind it, but the name of the system is the Haberman sphere. I would request Om to award Ganga House positive 10 points as partial mark. Next question is for Jhelum House. It's for Moumita and Srijan. This animation portrays the experience of a pilot witnessing an amazing weather phenomena. This was exactly the same phenomena which created an outstanding imagery in Coleridge's famous poem, The Rime of the Ancient Mariner. As a hint, I would like to inform you, Jhelum House, that unlike lightning, it is not the movement of electricity from a charged cloud to the ground. The pilot's experience is attached here within quotes.
I would also like to mention that this concept is not new to class 12 students, as it is included in their curriculum. You may discuss. Your time starts now.
Um, do you have any idea about this?
Okay, it is somehow related to the electrostatics chapter of class 12 present curriculum. You have to name this weather phenomena and the principle behind it.
Weather phenomenon.
Discuss whatever is coming into your mind.
Yes, can we see the audio again?
Will it be possible to play the animation again? Concentrate on the images. We can see that it is emerging from a very sharp point.
Concentrate on the images. Time up.
Do you have any answer or will I go ahead? Okay, so no answer means no points. The weather phenomenon depicted in the animation is a St. Elmo's fire, and the principle behind it is the corona discharge, or the discharge that happens through sharp points. Never mind, there are plenty of opportunities to come back. Jhelum is awarded a -5 points.
All other participants are requested to stay muted.
Yes, it is very important to stay muted in an online platform like this. So moving on to the next question, that is for the Kaveri house. Shayantika and Medhir? Yes. Please observe these two photos very carefully. Out of these two photos, one depicts the trajectory of Chandrayaan-2 and the other the Apollo 11. Your task is to match the trajectory with their respective space flights and point out the essential difference in their trajectories. Did you get the question? You have to say A corresponds to A corresponds to which space flight and B corresponds to which space flight out of Chandrayaan-2 and Apollo 11, and point out the essential differences only in their trajectories. Your time starts now.
Do you know, Medhir?
Wait.
Observe the trajectories very carefully.
You can notice that the blue one is taken in an anti-clockwise direction. It is orbiting to the moon. Wait. You have any idea about this? What?
Focus on the difference in the trajectories.
So as you can, from what I can notice, that they took from different places, and now they are landing at the same place, but their trajectory are different. The one is taking an anti-clockwise direction, other is taking a clockwise direction. So, wait.
Concentrate on the eventual path, not on what is anti-clockwise or is it anti-clockwise.
10 seconds left.
See the docking part for the yellow point.
Time up.
You can
Time
see
up.
that
I'm sorry.
the SCM.
Yes. Have you any answer?
Oh.
Tell it.
Please be fast. If you have any answer, please
No.
respond.
Till that
They just
only.
written the
Okay.
talking point. The talking point is a little
So
different.
no, I didn't get any. No, I didn't get any satisfactory answer. That means a negative of 5 points for Kaveri House. As we can see, the first trajectory labeled A is the Apollo 11 and the second one B is the Chandrayaan 2. The Chandrayaan doesn't have so powerful rockets that would hurl itself straight towards the moon. It takes a circuitous route to take advantage of Earth's own gravity that will help slingshot the craft towards the moon. On the other hand, Apollo 11 makes only one revolution around the Earth and undergoes a trans-lunar injection into the moon's gravitational field. While returning back from the moon, Apollo 11 follows the same trajectory. So may I request Om to move on to the next slide? Okay, now let me hand the proceedings over to Adrija to continue with the quiz.
Thank you, Sutirtho. Now, next question goes to Narmada House. Oh, may I have the animation, please? Carefully watch the animation, Narmada House. I hope you were able to comprehend from the animation. Observe the movement of the ball with respect to the dial beneath it. The perpendicular plane of the swing is not only confined to a particular direction, and it moves in any arbitrary plane. Identify this simple device and please tell its use.
Is it a sundial?
Can we look at the animation once again?
Yes, sure. Oh, may I have the animation again, please?
It is a special type of pendulum.
Narmada House, your answers? You are free to discuss it among yourselves.
Any idea?
As a hint, I would like to
Is the
mention that it is
pendulum
something related to the Earth's motion.
is the pendulum moving in like all four directions? Not clear from the animation.
Yes, it
It
is
is,
moving in all four
It is
directions.
Last 10
not only
seconds.
four, it is moving in all directions.
yes.
So I think the answer is Foucault's pendulum. The name of the pendulum.
Congratulations, Narmada House. That is the correct answer. A big round of applause. Okay, moving on to the next question to Teesta House. Identify this personality and name her contribution to the field of astrophysics in 2019. She is famous for developing the technology of continuous high-resolution image reconstruction using patch priors. You might note down the details of this question for the last round of Singularity.
Okay, her contribution was that she actually helped to program in the means when we had to image the black hole. She was the one who actually wrote down all the programs and how the means software would take out the image. Her name I don't remember. Olivia, do you have
Okay.
any idea? Olivia.
Yes.
Her name, her name.
You are moving in the correct direction. Go ahead.
Yes. I know. Means, uh,
We wrote the
uh,
pro- uh,
You got her contribution right, and you just have to identify her
means
now.
I'm bad with names that I know. Means, no idea. Means the name I don't know. I have no idea regarding that. So,
Okay,
10
we
seconds left.
just go with the contribution.
okay. Do you want to discuss further, or it's the final answer?
wait a second. I
Time
think
up.
it was something Katie.
It's time up. It's time up.
Katie. I think. I don't know.
Mrs. Kitty, whatever she said.
Do you? Okay, fine.
Katie, I don't know the title. Katie.
Okay,
And
no problem.
she contributed.
Okay, no
Katie, right?
problem. Okay, I think you got most of the answer correct. We are going to award you a total of 15 points since you didn't get her last name, but a very great, like, it's an awesome performance by Teesta House. Congratulations. I hope all the participants noted down the details of this question as it is important for the last round. I'm handing it over to Shreya now to update us with the scores at the end of the round 2.
Thank you, Adri. This was a very exciting round, but we have a number of ties here. Let me first announce the ranks. In the third position, we have Kaveri House with a score of -15. In the second position, we have Narmada, Chenab, and Jhelum tied with a score of 0 points. And in the first position, we have Ganga and Teesta heading the scoreboard, tied with 15 points. Since we need to break the tie for the next round, I hand over the proceedings to Om Mahapatra to do the needful.
Thank you, Shreya. Before the tiebreaker round, all the houses that will take part in the tiebreaker, I'll mention the houses which will take part. You can send in only one answer for each tiebreaker question from one participant each. So please decide it right now who will be the participant. Chenab House, who wants to send in the answer for the tiebreaker?
Mrinma, you send it.
You go for it. Are you sure that I can?
Yeah, you
Do you
send
want
it.
to? You will go or
You.
okay?
So
Then I
Mrinmoy?
will go.
Okay. Ganga House?
Jyotirmoy, you want to go?
I have no problem with that, but like, are you fully prepared for the thing? So like, you can.
You need to make it
No,
fast.
this
We
time
are already running short of
this time
time.
you go.
Okay, no problem.
Jyotirmoy
Okay,
from our side.
Okay. Jhelum House? Please decide fast.
Do you want to go? Or do I go?
Please make it fast, participants.
Okay, let's take Momita.
Okay, Momita. Narmada House?
Ayok, do you want to go for it?
Sure. You'll
Who's
go.
this?
You'll go or I'll go.
Exactly, if you go. Okay, I'll go. Fine.
Porno. And Teesta House?
Olivia, I'll go for this round.
Okay.
Okay. So first, we have a tiebreaker for Chenab House, Ganga House, and Narmada House. The participants are Mrinmoy, Jyotirmoy, and Shoporno. When I show you the question, you'll have a deadline of 30 seconds. You'll have to send the answer as soon as possible to Shubhoji. Keep in mind that in case of all the answers being correct, we will take the fastest answer. The first question is now.
Mercury is not the hottest planet in our solar system. True or false? Chenab, Ganga, Narmada, go. 15 seconds left.
Which houses can answer?
Chenab, Ganga, and Narmada. Time up. Shojit, has any correct answer been answered?
Yes, I have got two correct answers. One from Jyotirmoy Day of Ganga.
Okay.
And could you go back to the question once more? Yes, I have got two correct answers, one from Jyotirmoy and one from Suporno.
Okay. So
Suporno is from Narmada and
yes.
Jyotirmoy is from Ganga.
The next tiebreaker will be in between Ganga and Narmada, that is Jyotirmoy and Suporno. Same rule, you have to send it to Shojit again, and 30 seconds the deadline. I'm sorry, the actual answer is Venus. When two boats move close to each other, they feel an attraction. Name the principle. Don't need to state the principle, just name the principle. The time has started. Ten seconds left. Time up. The actual answer was Bernoulli's principle. Shojit has.
I got no answers.
Okay. We move
Okay,
on
so
to
it
the
is decided that Ganga will decide first. So Ganga is out of the tiebreaker.
Ganga will decide first. Because
Ganga will decide first in the final round.
Yes. For the next tiebreaker, we have Sat. Okay, so that is decided.
For the second position, we need to do another tiebreaker. Okay, second position will be maintained, chosen by Teesta House. And for the following, we need a tiebreaker.
No, it's done. It's done. It's done. Adrija, please continue with Event Horizon.
Yes, so now we move on to the third round of this quiz, Event Horizon. Event horizon is the space around black hole from where nothing, not even light, can escape. The round will be conducted as follows. Participants are to keep their videos on at all times. Correct answer fetches your house 30 points. No negative marking is here. All the questions are required to be answered. Participants will be allowed to choose questions from the 6 topics in order of decreasing marks accumulated in the previous rounds. During the 1.5 minutes of discussion time given, only the members of the team can unmute themselves and discuss among themselves. The decision of the quizmaster is final and binding. Oh, may I have the 6 topics?
Yes.
Yeah,
Mr.
your
House,
topics are.
Allowed to choose first. Please choose. Teesta House.
Yes.
Please choose.
What? Can you repeat?
You need to choose one of the
choose your.
Oh,
topics are listed in the screen. You need to choose one out of them.
We'll go with classical mechanics.
Something which is easy. Yes.
Classical mechanics.
Ganga House, go next.
Jyotirmoy, what do you want? What do you want to take? 6.
Are you good at relativity?
No, not that much.
I can manage a bit, or like,
Okay,
can we go?
Yes.
Okay.
Then relativity.
Okay. Narmada House.
I'm thinking about environmental physics. You want to go with it?
Yeah, sure.
Yeah, environmental physics.
Okay. Jhelum House. Jhelum House.
Astrophysics.
Or take applied physics.
Okay, fine. Applied physics.
Okay. Chenab House.
I think whichever.
Is particle physics taken?
No, it's still open.
Uh, we'll go for particle physics. Is it
Okay,
okay,
and
Mrinma?
Yeah, it's
okay, and I think astrophysics is left for Kaveri House. Perfect.
Could you please repeat which houses have chosen
Yes.
which topics?
Yes. Teesta House has chosen classical mechanics. All the houses, if I'm wrong, please correct me. Ganga House has chosen relativity. Narmada House has chosen environmental physics. Jhelum House has chosen applied physics. Chenab House has chosen particle physics, and Kaveri was given astrophysics. So, if you want, we can show you the rules of this round again. Adrija, please read out the rules again.
Yes, sure. Participants are to keep their videos on at all times, and correct answer fetches your team a plus 30. Negative marking is not there. All the questions are required to be answered. The participant will be allowed to choose questions from the 6 topics which were given to you. During the 1.5 minutes of discussion, only the members of the team to which the question is being asked can unmute themselves and discuss it among themselves, and the decision of the quiz master is final. Oh, may I have the first question from classical mechanics for Teesta? Teesta, this is your question. In his book, published 101 years after Newton's Principia Mathematica, the scientist X gave an alternate formulation for the classical mechanics, which was completely different from Newton's method but yields the same results. This new method, based on the principle of least action, requires us to write the difference between the kinetic and potential energies of the system in terms of independent coordinates, denoted by L, taking the derivative shown above and then solving for x dash and x. Here x dash is the time derivative of x. The surprising thing is that this formulation of mechanics requires no in-depth knowledge of physical quantities like forces and torques, and X often boasted how his book did not require even a single diagram. Identify the scientist X. Teesta, your time starts now.
Please feel free to discuss with your partner.
Olivia, do you have any idea?
No.
Nice.
Wait a second. We have 1 minute and 30 seconds.
Okay. Okay. Difference between
Just at
kinetic
least
and energy differential with respect to x, and x is the difference. Means if you differentiate energy with respect to x, we will get work done into the work done, that is, and L is the.
You need to identify the scientist.
It greatly simplifies Newtonian mechanics.
The second paragraph is not really necessary to answer the question.
Simplified Newtonian mechanics. Olivia, did you say something?
No.
10 seconds left.
Who simplified Newtonian mechanics? Wait a minute. It's delta. I think that it looks something like similar to Schrodinger equation.
Time up.
No. It's classical, yeah.
Time up. I'm sorry.
Short
Time.
answer.
No, leave it.
Okay, the answer is Lagrangian mechanics. His book was Mechanic Analytic. It was published 101 years after Newton's book. Okay, moving on to the next question for environmental physics. Narmada has taken up the topic. May I have the question, please? Okay, so the question goes to Narmada. X is the name of the family of optical phenomena produced by light, typically from sun or moon, interacting with hexagonal ice crystals suspended in the atmosphere. X can have many forms, ranging from colored or white rings to arcs and spots in the sky. Among the best known X types are the circular X, properly called 22-degree X, light pillars, and sundogs, parhelion. X is also the name of an American military science fiction video game franchisee whose original trilogy centers on an interstellar war between humanity and an alliance of aliens, also known as the Covenant, named the phenomenon X.
Sukarno, is it Nova?
One sec.
You might take the hint from the pictures.
One sec. I think it is X is hello, I think.
Hello. Yes.
Hello.
That is your
It's
final
hello.
answer?
Yeah.
I'll take that as
Hello.
the final answer. Okay. Oh, may I have the answer, please? That is your correct answer. Congratulations, Narmada House. Amazing performance. Great job. Now I would like to hand over the proceedings to Shubhojit for conducting the quiz.
Thank you, Adrija. We now move on to the next question on astrophysics for Kaveri House. Medhir and Shantika. Are you ready?
Yes.
Okay.
Yes.
The man standing beside Superman in this picture is a real living astrophysicist X. In this recent cameo in the DC comic universe, the physicist is trying to help Superman search for his home planet Krypton. In real life, X is often accused of single-handedly kicking Y out of the solar system, while he himself denies being the actual culprit. Identify X and Y.
You have any idea? This.
Thinking, I have no idea. You have any idea about this?
I don't.
Read the second paragraph. You might get a hint.
Yes, the second paragraph.
You will be awarded partial points if you name any one of X or Y. Go for Y.
Yes, Y is more or less easy.
Maybe can you do?
Think about something that once held a position but does not hold that position any longer in our solar system.
Pluto.
Do I take that
Pluto.
as your final answer?
No, wait.
Please maintain the time.
Yes,
Pi can be Pluto. And
10 seconds left.
Well, maybe tell it.
Why
I don't know
Pluto?
about this.
Time up. We move on to the answer. The answer is Neil deGrasse Tyson, and Y is, as you correctly pointed out, it's Pluto. Neil deGrasse Tyson was the man, the astrophysicist who was responsible for popularizing the opinion that Pluto should be demoted from the position of a planet to that of a dwarf planet. Well done. So we move on to the next question on applied physics for Jhelum house. Srijan and Momita, are you ready? These are images of the original experimental setup used by a scientist to measure the value of a fundamental constant of nature. Apart from evaluating this constant, the experiment also demonstrates the conservation of the physical quantity involved, which had previously been thought of as a continuous variable distribution. Name the scientist, the experiment, and the physical constant.
Concentrate on the apparatus that is set up. We can observe a dropper.
Any idea?
No, like, is it?
Jhelum House, this is included in your curriculum.
Like,
Utilize the time
this
discussing.
elaborated? Like, it is very difficult to make out from the picture.
This is a very famous experiment by a certain scientist who discovered
seconds
the
left.
value, the numerical value of a certain physical constant. The constant was initially thought to be a continuous distribution, but now it is known to be discrete.
Time up.
Okay, then no answers from you.
Okay, is it torricelli and atmospheric pressure?
No. Move on to the answer home. It's Robert Millikan, the Millikan oil drop experiment to find the value of electronic charge. So we move on to the next question for Chenab house on particle physics. X was a particle discovered in 2012 in an instrument Y, which the Google Doodle commemorates, at the Institute Z, which led to the printing of this advertisement by Amul. Name X, Y, and Z. As a hint, I will tell you that X is the fundamental particle in particle physics, which is responsible for the property of giving mass to all other particles. This is quite a recent discovery, so you might be able to answer it.
Any idea?
Hello, Myanmar.
It was actually the result of a very long search.
Yes,
All the eminent scientists of the world gathered in this place to discover it.
the existence of this particle was proposed a long time back, but it was experimentally verified for the first time in 2012.
Myanmar.
Yeah.
Is it a particle accelerator? Can you recognize it?
Please be specific.
Particle accelerator.
Name the particle accelerator.
Myanmar, can you?
It can be something.
It was something hadron collider. What's the name?
Yes, almost.
Please.
10 seconds left.
No, I cannot.
Time up.
We'll move on to the answer. X is the Higgs boson, also known as the God particle. You should have noticed the Amul advert closely. Y is the Large Hadron Collider, and Z is CERN. You will get a partial mark of 5 for Large Hadron Collider. For Hadron Collider. Please move on to the next question, Om. On relativity for Ganga house. Suppose an astronaut A, standing on the surface of a white dwarf star, is sending a signal every minute to his fellow astronaut B, who is orbiting the white dwarf star on a spaceship at a distance. Both of them have synchronized clocks. All of a sudden, the mass of the star exceeds the Chandrasekhar limit and it starts collapsing under its own gravitational influence until it reaches the Schwarzschild radius, after which it is essentially becomes a black hole, and no signals, not even light, can escape from it. Throughout the entire process, astronaut A had been sending signals every minute by his clock. For astronaut B, how does the time between each successive signal he receives vary? That is, does it increase, decrease, or remain constant? And name the phenomenon responsible for this.
Again?
Participants of all houses are supposed to know that this is also a connect question part. So please note down any details that you find important in this.
Pragyan?
Yes.
Hello. It is basically time dilation, that's for sure. And
yes, time dilation.
Time dilation. And
how does the separation in time between each successive signals that astronaut B receives vary?
Pragyan, hello.
Yes.
Yeah, the person on the like dwarf star that like exceeds the Chandrasekhar limit.
Yes, for sure.
Obviously, is for him the time should go much slower as compared to the one who is orbiting it.
Yes.
Go on.
Right. So you need to just answer
who is orbiting, the time will go faster.
How does the astronaut B interpret the difference in time between each signal he receives? Increases, decreases, or remain constant?
Increases, decreases, or remain constant?
It's constant.
No. I guess it will
won't
not
remain constant. That is for sure.
You are almost there.
Will it increase because a signal will then not even reach?
For astronaut B.
What is your final answer?
Yes, I think it will increase.
Increase.
It increases and the phenomenon is time dilation, right?
Yes, it's time dilation.
Should I accept this as your answer? Okay. So your answer was absolutely correct and you get a perfect score of plus 30 for your effort. That is because for astronaut B, for astronaut A, since time runs slow for him due to increasing gravitation of the star, what he perceives as a minute is much longer than what astronaut B perceives as a minute. So I hand over the proceedings to my friend Om now to conduct the rest of the quiz.
Thank you, Shivaji.
Welcome.
We will just take a look at the scoring after point of no return event horizon. We have Jhelum and Kaveri tied together at 0 points. Just in front of them, we have Chenab house with 5 points. Then we have Teesta house with 15 points. Then we have Narmada house with 30 points. And in the lead, Ganga house with 45 points. Participants were requested to note down details about connect questions such as this one for the round 4, which is singularity. Like the other rounds, participants will keep their videos on. There is only one question which, if answered correctly, awards the team 50 points. If no one can answer the first question, we move to the first hint, which, if answered correctly, awards 40 points. If no one can answer the first hint, we move to the second final hint, which, if answered correctly, awards 30 points. This question is open to all, and each team can send only one participant to answer it in a deadline of 2 minutes for the first question, 1 minute for the first hint, and 30 seconds for the second hint. Lastly, the decision of the quiz master is final and binding. First, we have to decide the participants from each house. So, Chenab house, who is the participant?
Mrinda, I'm sending it.
Yeah, you go.
Who is it?
Rintik will go.
Okay. For Ganga house?
This time who will go?
Pragyan, you want to go this time?
Okay, I'm going in.
Go for it.
Please say your name.
Proggayon go raha
Pragyan, go right.
Jhelum house?
Should I go?
I'll go.
Who is it?
Srijan
Who is
Bose.
it? Okay. Kaveri house?
You wanna go?
Please decide quickly.
Maybe you go. Okay, I'm going.
Medhir? Okay. Narmada house?
Shayok, you wanna go or I'll go again?
I'll go this time.
Okay.
Who is it?
Shayok.
Kayok.
And Teesta house?
I'll go. Sarthak.
Okay.
All participants who have chosen to answer must text the answer via the Zoom chat to Shubhajit. Zoom chat personally to Shubhajit.
Okay. So here is the question.
Only one person can answer. No?
Yes, only one person can answer. The following images from questions from the previous rounds are all connected to one eminent theoretical physicist. Who? The first picture is a diagram of a Penrose diagram. The second picture is of Katie Booman. The third picture is of University of Cambridge. And the fourth picture is of a black hole.
And
Okay, I have a question.
unmute themselves right now. No one is supposed to unmute themselves
answer in
right
the
now.
chat box.
No form of verbal answer right now.
Like, I have a question. Like, are we allowed to have only one try, or we can try for every?
You can try for
You
every.
can try for
this, and
every.
then for the first hint, then for the second.
Yes, trial is for every round.
There
He's
is
a
no
scientist,
negative.
right?
But
He's
the
a
marks
scientist,
are in
right?
decreasing order.
Yes. Plus 50,
50
plus
for
The
the
marks
first
will
try, 40.
marks will
then
gradually diminish.
Is this open for all the houses or just Chenab? Means
Yes, yes.
it will go house wise?
Open
All
for
house.
all house.
Okay. And is there any negative points?
No, there's no negative.
Okay, thank you.
This is like a jackpot question.
The first picture is that of a Penrose diagram. The second picture is that of Katie Booman. The third picture is that of the University of Cambridge. And the fourth picture is that of a black hole. 20 seconds left.
Pragyan, which house are you from?
Ganga house.
Ten seconds left. Time up. So Tirtho, has any participant sent the correct answer as of yet?
Yes, we have correct answers. We have correct answers from Chenab, from Teesta, from Narmada, and from Jhelum.
Chenab, Teesta, Narmada.
And also Kaveri.
Jhelum. So we move on to the next hint, only for Ganga House, to see if they can answer it.
By the way, one thing. Medhir has attempted twice in this turn.
Was his first answer correct?
No.
Can I say? In the first time, I actually wrote about a phenomenon. Then I saw the physicist.
There was no
wrote a
phenomena.
name.
You should have
There's no phenomena.
written the name of the scientist. So your answer will be evaluated as part of the second round of the question. Second part of the question.
This famous scientist has co-authored this popular sci-fi series with his daughter. You'll get 1 minute for this.
Those who have given the answer cannot write again, right?
No.
No.
It's the same.
No, only those who are
No.
left will write the answer.
If you have answered incorrectly, then you can attempt.
Okay, got it.
Did I answer? So this one.
Edhir, you can answer.
Is this question house specific or like?
This is open to all. Ten seconds
I
left.
have submitted my answer.
Time up. Shivajit, have you received answers from Ganga and Kaveri?
Yes, I have received answers from. By the way, I have received answers from Narmada as well. Yes, from Ganga I have received the correct answer, and from Kaveri also the correct answer. Why has Narmada attempted once more?
Narmada, you will be awarded only for the first. Not
First.
Right. Sorry. I thought that.
Yes, go ahead.
Okay, Kaveri and Ganga have answered correctly now in this turn.
Okay, that's it for this round. We have a tie in between Ganga and Narmada, for which we'll go to the tiebreaker. But before that, I'll just show you the answer. It is, as all of you have guessed correctly, Stephen Hawking. The first one was related to the Penrose-Hawking singularity theorems. The second one is black hole, Hawking's specialty towards his end years. The third one, University of Cambridge, was where Hawking got his PhD from, and black holes again, obviously. Even the names of our rounds, ergosphere, photon sphere, event horizon, and singularity, are different regions within a black hole. And this was our first move towards this answer. We will move to the tiebreaker questions between Ganga and Narmada. Please give me a second.
Do we have to type in the chat box?
Yes,
Or
the same
The
rule.
last round is already over, right?
The person who
this
is
is
selected, he's the one who'll write.
Yes, from this round only. So Pragyayan and Shayok. I'm showing the questions. You'll have a deadline of 30 seconds to send it to Shivaji. Now, this acts as a reference for a sailing ship to judge the maximum and the safest depth to which it can float after being loaded. Name it. As a hint, I can say that it is printed on the side of a ship. Ten seconds left. Time up. Shivajit, have you received the correct answer?
Yes, both of the answers are correct, in fact.
Okay, so we move on to the next tiebreaker. If two pieces of the same type of metal touch in space, they will permanently bond. Just name the phenomenon. 30 seconds again. Time up. Shubhajit have received the answer.
I haven't received a single answer. I have received one answer, but it is incorrect.
Okay, we move on to the next tiebreaker. The answer to this, by the way, was cold welding. For this tiebreaker, you will have only 15 seconds, so send it as soon as possible. What is common in Olympus Mons, Tharsis Rise, Eowastrid, and Mac Mons? Start. Ten seconds left.
By the way, why is Shayak Das of Narmada answering?
He can answer. He can
You're
answer.
supposed to answer. Oh, I'm sorry.
Have you received the correct answer?
I received two answers, one from Shayak, one from Pragyayan, but none of them are the correct answers.
Okay, we move on to the last tiebreaker. The answer
Please
to
tell them
this
the answers. Yes.
is that these are the names of outer space volcanoes. What is the time period of Sun's rotation around its own axis? 15 seconds. Go.
Pragyayan has
Time up.
answered correctly.
That settles it. So Ganga wins this tiebreaker for now. Please give us a minute to accumulate all the scores.
Will we get any point for tiebreaker, or is it just a tiebreaker?
No, no. You'll just get 5 points for the correct. So Ganga won 5 points for this.
Okay.
It just settles the tie.
Please give us 1 minute to accumulate all this.
Got it.
Meanwhile, we are all extremely glad to see a participation like this, exemplary participation from all of you. Even we got some new opportunity to. Even we got the opportunity to learn new things. It's not that we, the quiz masters, know everything, but we also got a new opportunity to learn various things.
Is absolutely
We are
correct.
extremely glad.
Photophysics has been designed and conducted by 7 members of our very own physics club: Obronil Mitra, Adrija Chattopadhyay, Avi Saraf, Om Mahapatra, myself, Shreya Dev, Sutirtha Ghosh, and Shubhajit Das. Now, I would like to hand it over to Suprabhat sir to announce the final scores and give the vote of thanks.
Okay, good evening to everybody. So it was a thrilling experience on my part, children. And truly speaking, 2-3 years ago, I named this particular physics quiz as photophysics. Why it was named photophysics, that you should know first. It was named photophysics, children, because every year we always have decide the winner in a photo finish. So always it's a photo finish every year. So neck and neck fight this year also. I thank all the participants over here, because I can tell you one thing. I will tell that is total physics is the winner today. So it actually gives us a very good opportunity to actually see that how our legacy of DPS Ruby Park is being carried by the future legends like you people. It's absolutely, I just congratulate everybody. It was really a marvelous presentation on behalf of the physics club and also by the participants. So first of all, let me, before I just announce the winners, I will just like to give a vote of thanks to all my respected principal ma'am, vice principal sir, vice principal ma'am, and all the teachers and the coordinators of DPS Ruby Park who had been really inspiring us for to have this particular quiz, Photophysics 2020. And today, the grand success of Photophysics 2020 is all because of our beloved students and our teachers and my colleagues and my hierarchy. Now, one thing I like to tell you, because I cannot miss out this, I should thank each and every one of you, one of the member of physics department. Especially, I would like to thank Shomi ma'am. She had been just on her toes from the day one because he was the in charge of this Photophysics 2020, along with Dipanjan sir, along with Shomita ma'am and Partho sir. An entire physics department has worked, and all this, I always name these 7 people, that is Obronil, Odrija, Obi, Om, Shreya De, Shutirtho and Shubhajit as my Vivjior. They are the actually 7 colors of this white light. And today, the grand success of physics quiz is all because of you and the members. So thank you very much. But one thing I will end up before telling, I should not, is in this pandemic situation, every corner of this world is fighting Corona. Every corner is fighting with COVID. And today we have got a real fighter in our team. I should name her, Shreya De. She had been conducting this physics quiz today from the bed on the hospital, PLS hospital. She is fighting COVID-19 over there. We should give a big round of applause for her because she had conducted this particular quiz from the hospital bed. I thank you, Shreya, and we all pray for you that you get well soon. And finally, everything that waits, because we have to have a decorum that who actually won the score, but everybody has won. Now let me just tell the score. I will tell from the ascending order. First of all, Kaveri has got 40 points total. Then Jhelum with 50 points. Chenab 55. Third is Teesta, that is the second runner-up, is Teesta with 65 points. And the runner-up is Narmada with 80 points. And winner of Photophysics 2020 is Ganga with a very thin lead of 85, and that was decided in the tiebreaker. Excellent. Ganga and Narmada fought till the end. It was a real breathtaking things, and we always keep our fingers crossed that who will win. Nobody knew, but it was just a last ball affair of T20 match. Thank you very much. Thank you so much for being here. And I also thank all the audience over here, because many people has today gathered to see this particular Photophysics, which is actually undergoing a live streaming. So I thank you all the audience over here to keep us going and motivating. Thank you all, and hope for another round of Photophysics 2021 next year. Thank you very much. Thank you so much. God bless you all.